All right, we're going to start some fun for the rest of statistics here. We're going to do labs, which use the statistical concepts that we have been talking about. So our first lab that we're going to participate in is probability pigs. So what happens is we have got these cute little itty bitty pigs right here, okay? And of course, they are going to land very differently every single time. They don't always land. It's not like a regular die, which we expect to be 1/6 of the time on the ones, 1/6 of the time on the twos, and so on. So we're going to test the claimed probabilities that are for this. And now, one thing we haven't discussed, but in AP statistics, we go into this in depth. In order to have a sample size that is quote unquote large enough so that the sampling distribution will be approximately normal, our sample size, so the number of trials, how many times I'm going to roll this pig, times the claimed probability of what I'm looking for has to be greater than or equal to 10. So for example, the first thing that we're going to be looking for is if the pig lands on its side with the pink side up. On the next page, you have it here. I wrote it as side dot down. It's on its side, but the dot is down, and that will land that way about 35% of the time is the claimed probability. So if we go put this into the formula, sample size times the 35% probability here, okay, it has to be greater than or equal to 10 to be large enough to make a sampling distribution that's approximately normal. So then we'll algebraically solve. So I would divide by the 0.35 on both sides, divide by the 0.35. So 10 divided by 0.35 is 28.57. Well, you can't roll the little piggy 28.57 times. So we have to round up because that's at least that many. So 29 is the minimum amount of times that you have to roll this pig to get a representative sample of what it's going to do. So what I'm going to do is I'm going to roll this pig, and so I'm going to start counting. Okay, 1, and it did not land this way. So that was 2. It keeps landing on its feet. Interesting. 3. Oh, nope, that's not it. 4. Nope. 5. Okay, that was this one here. So I'm going to do that. Okay. 6. Nope. 7. Yes. Okay. 8. Nope. 9. 10. No. And so on. So once you finish, however many tallies that you get, okay, then you're going to state what your sample proportion was. And your sample proportion was, if I had run this 29 drops of the pig, then here I would have gotten 7 out of 29 as my proportion, and then I would figure out what that is as a decimal, because in a minute we're going to run a test. All right, so you're going to do that then for these other pieces. So for the next one, side dot up, which is claimed to be 30%. So I need to say, oh, n times p needs to be greater than or equal to 10. Okay, n times this p, which is 0.30, needs to be greater than or equal to 10. And then I'm going to solve it. N needs to be greater than or equal to 33.3, repeating. So I need to roll my die 34. Now, here's something else that's important. This is a separate set of 34 rolls. It cannot be these 29 plus, 5 more. No, it has to be independent. It has to be an independent sample. That's another thing in AP statistics we talk about why this condition has to be met. Okay? Well, and I think it should make sense to you. If I roll this little piggy, and for some reason, I get an unusual sample that is really, really a whole bunch of times with the side dot down, then if it's way heavy on the side dot down, then it might be just less naturally on the side with the dot up. So that is not independent samples. So therefore, my little piggy, for this one, I have to do a separate set of 34 rows and then find what that p hat is for that set of rows. Okay, so that's how we do that. All right, and then you will go through and you will collect all your data and you will have a p hat for everything. Now, these last two, the sample sizes are huge. So you might consider collecting data from multiple people. You say, hey, you do 100, I'll do 100, or I'll do 150, or I'll do 200, whatever, and then we'll combine our results together. Okay. All right, now what? What are we going to do with our results once we have them? Well, you are going to run a statistical test to test the claim. So let's do this first one together here. So, for example, this is the first picture that we tested. Test the claim that the proportion of times the pig lands side dot down is 35%. So I'm going to write in my parameter, and that's P equals, I'm going to do a different color here. So P equals the proportion of times the pig lands side dot down. All right. So that's my parameter, the proportion of times the pig lands side dot down. Okay, so what is this null hypothesis? What is your HO? Well, our HO is going to be, of course, that P equals the claim, which the claim was 35%. Now, here we have HA colon P is, now I don't know which way it's going to be, so I'm going to do not equal to, so I need to come on over here and put myself a little slash through that, not equal to 0.35, which we'll address in class doing a two-tailed p-value, but you know how to do a one-tailed p-value, and so we'll have that happen. So here, look at our p-value. So we know then that we have the 0.35. Okay, which means, of course, that the center of all the samples will be centered around 0.35. Let's see. This is your sample size. Okay, so what sample size did you do? Some of you may have done a different amount. Some of you may have done 30 instead of just 29. Okay, so however many you did, put that there. This is your individual results. Now, then, we're going to have to do this thing here where we've got, of course, the square root of the 0.35 times the 1 minus 0.35 over your n, however much your particular n was. Okay, so I don't know what this number is. I'm going to totally guess. Okay, now what about this p hat? That is this here, your sample results. So again, everybody has different results on that. Okay, so here I'm going to put, if I got 7 out of 29, then I'm going to figure out what that proportion is. I don't know what that is, so I'll figure that out real quick. Okay, because then I'm going to use that in my z-score. 0.24. All right. And then you know what to do from here. I'm going to do my z-score. It's going to be my p hat minus the p over the standard deviation. Okay, I don't know what that is. But once you do that, if you have a negative z-score, do your p-value more extreme. If you have a positive z-score, do your p-value more extreme. So based on if you have a negative z-score or a positive z-score, that will tell you how to get your p-value by norm CDFing from negative 99 or norm CDFing to positive 99. And then the rest of this is what you're familiar with. Compare your p-value to alpha, and if that p-value is low, reject HO and conclude. So if you reject HO, then you conclude that the pig lands on its side a different amount than 0.35. Now, you don't know what that is, but you can say it is a different amount than 0.35. Okay, so that is how that works. And so you are then going to run a statistical test for each position that the pig could land in. And we're going to see if we have any unusual results that we can reject the claimed percentage. All right, that is then what you will upload for your assignment is your work on your tests that you ran on your data. All right, so good luck to you, and I hope you enjoy rolling your pigs.